So the first thing you should study is a layout of line count for different directories. The kernel module is 25,000 lines, the compiler is 20,000 lines, and then everything else goes in the Atom directory. Applications you don't need to pay any attention to. The demos you don't need to pay attention to. Linux is just the uncompress that runs on Linux for uncompressing the files. The miscellaneous directory doesn't really have any code. It has the operating system test suite. If you want to study how to puppet applications. Then there's the accounts directory. This is my own personal code. Anyway, so basically, like I said, there's the kernel, 25,000, the compiler, 20,000, and then Atom, which is everything else. So Atom includes the graphics, 12,000, the editor document framework, that like the tree we're looking at, and it has miscellaneous stuff in the utilities. There's grep and stuff like that. Anyway, so we have. Let me go ahead and I wonder if this will work. I just want to not distract you with. Take away some distractions. Kind of stupid. Okay, well, anyway. So there's the kernel, the compiler, and Atom. Okay, so let's go over the kernel. There's a scheduler. It's round robin. It can save a context and restore a context in 450 or 4,500,000 times a second. Watch this. While true, yield. Control. Oh, I screwed up. Hold on a second. Control Alt C, Control B. Now we can look at the map. Swaps per second. So I'm also doing a frame grabber. Oh well. Anyway, so the fact that I can change task 4 million times a second changes the programming style, along with the fact that this is for a personal computer, not a mainframe. So let me just get right to the core of the matter. When you're doing a disk task, it stays in a loop and yields until while the status is busy. So in other words, we do synchronous I/O. One of the things you learn about a PC operating system is try not to make it incompatible. Every single computer is different with different devices. That's the first thing you learn about. Let me tell you a story. The first system I did, I tried to use ATA multi-read, or not multi-read. I tried to use this is these are the disk commands. There's one to read multiple blocks right here. It turns out if you try and read a single block, the first system I had, I sat there trying to read a single block and it wouldn't work. Then finally, for some silly reason, I tried reading multiple blocks and it worked. So in other words, some hard drives support multiple blocks and not single blocks. So the first lesson of a PC operating system is compatibility is the most important thing. So in other words, interrupts unless you know the professional way, which is really big, ugly, and nasty, don't use interrupts because of compatibility. That's the reason I try to keep it simple. So synchronous I/O, that's because of compatibility. Now, you can analyze, you know what's going to happen if you have 5 tasks doing disk access. Actually, it only allows 1 at a time. But anyway, yeah, there's a, let me tell you something. Computer people are snobs. Nobody would ever be caught not using interrupts because of snobbery. It's the instant humiliation if you don't use interrupts. So, if you ask somebody how much time does polling the mouse take, guess what? If you sit there and you say, well, true, let's just do this. If import, I'm not actually going to do this. 64, and let's just say something like this. If, and then let's print a dot. Sleep 1 millisecond. If you ask somebody, let's suppose you had a task whose job was to drive the mouse. If you ask them how much time would this take, well, guess what? It's sleep. This takes about a microsecond, a millionth of a second. This sleep is for 1 millisecond. So what we're doing is we're using 1,000th of the CPU power. Now on a home computer, you could do that. There would be no. What people assume is that you sit there without yielding. Nobody would sit there without yielding. That's what you don't understand. So like in my disk code, I yield the CPU. Now you can talk about starvation and deadlocks and all that, but on a home computer, there's no reason to play 2 video games at once. Why would you play 2 video games at once? That's silly. So what my goal is to provide, first of all, it has to be compatible to work, but also I like it because it's simple. If you can do it simply or complicated, anybody can do it complicated. It takes a genius to do it simply. Well, anyway, so that's my little flame, if you want to say flame or something. Anyway, so yeah, my kernel, we can go down the list. This is like autoexec.bat. It's not linked into the kernel module. It's executed at startup. This is Pci Bios, which is how you access PCI devices. I try not to use that. Compression. This is LZW compression. It's you see all these with the .z. Those are compressed. Data types. I have a FIFO and a what do I have? FIFO and a Q and a linked list. It's kind of silly. Anyway, date. I use 64 bits for the date, and the upper 32 is day. The lower 32 is time of day. I have some debugging routines. I started with string indirection. Now I don't use it. I try to use strings directly. But anyway, I can show you a neat trick. Watch this. Control L. Now we do a widget, a text widget, whatever. This does not get kept. We're going to do this is a defined string. Let's say company, DD company. Now watch this. Okay, if I hit Control T, there's a text widget there and it's empty. Now if I say pound define dd company, it springs into existence. The screen is updated 30 times a second. The whole screen, everything. We can redefine this. Let's just call it redef. I don't know, whatever you want to call it. Company. So this is, if we say who minus R, I forgot if it's big R or little r. So it stores the compiler information goes into a hash table. There's a the hash table holds different types of items. If you make a function or a class or a define, there's a mask. Anyway, let's just go through this quickly. There's an emergency editor if it doesn't boot because of scripting errors because it boots. I do exceptions. I do a more practical, efficient exception handler. Anyway, I don't do the full C++ exceptions. Here's a font. You can change it, play with it. That's what it's for. I use VGA mode 640 by 480, 16 color. I don't use text mode. Looks like text mode. That's because I like it like this. Anyway, so hash table. You have graphics and source. You can do diagrams in the source code. So one of the main data structures is the hash table, system hash tables. There are linked lists it's an array with a bunch of linked lists, and I store different types. There's a bit mask that you can look up the different types, HTT hash table type. So these are, I have 32 bits. Import, export, symbols, define, global variable. This is a class, as in a C++ class. Function. I should be talking about this. The internal type is a special kind of class. A function, C++ function. This is for, what is this for? This is for the autocomplete. I'm not sure. It's a separate table. I don't have to have a separate type. A new table, we can start with new bit mask. Anyway, dictionary word. If you're wondering how we, I use a hash table to look up words for. This is like for spell check kind of thing, except I don't really have a spell check. Anyway, keywords for the compiler, assembler keywords, opcode. The assembly opcodes are in this table. Actually, I think they have a separate table. Register, assembly register names are in the hash table. You can have resident files. If you have removable disk, maybe you don't want your account files on disk. You want them in memory, so you can change the removable disk. There's not really that. We're talking CD-ROM. It used to be floppies, but not anymore. A module, that's not really very important. Help file. Frame pointer is supposed to be for if you have if you want global variables that interact with a DLL. Anyway, type mask. Okay, well that's the type mask. That's all the types. So where was I? So there's a hash table. Does neat stuff. Interrupts. There's a fault handler. There's a simple timer interrupt that runs 1 kilohertz no matter what. I don't do any fancy scheduling. Did I already talk about the scheduler? Anyway, oh well. When you compile the kernel, you have to answer configuration questions. This is I put this at the end. It's the main routine for during initialization. It starts and then jumps to the end. And anyway, externs, global variables, startup code, keyboard device. This is not very important. My math routines, anyway, nothing. Malloc, okay, I identity map everything right here. 128 gig no matter what. Identity map with 2 meg pages for the most part, except for the first page. There's a code heap and a data heap. The lowest 2 gig is for code. That's so that you can use the call relative 32 exclusive. There's only one way you call functions, call relative 32-bit. Anyway, so I have Malloc and free. Basically, I use we have, everything is identity mapped, so it will fragment, it will need to reboot, but it never happens in practice because you play a video game, you're done, play another video game, you can reboot, probably you do something else. Anyway, you reboot a lot, just in normal operation, it should be okay. You should never have to reboot. Because it's natural to reboot. Anyway, once in a while. So multiprocessing, you can assign either a job to do once, or you can tell the scheduler to put a task on a different core. It's master-slave, not symmetrical multi-core. It's better because if you're doing a flight simulator, you don't want the scheduler to get smart and put 2 jobs on one. You want 1 job per core. You don't want a real-time flight simulator to have 8 jobs and to put 2 jobs on 1 core just because the scheduler decided to. No, you want 1 job per core. Keep it simple. Put it there. Anyway, PSEX, this lets you, this helps you do source debugging. You can get I can unassemble any address. It's all identity mapped. This happens to be in the low 640. There's some stuff. We get symbolic debugging. The kernel module goes in the low 640 during boot. Everything else is, we have 64-bit address space. Anyway, PSEC, okay, so I have QSort. I have a couple specialized variations for 8 byte elements. It's 8 byte elements. If you know it's 8 bytes, you can, anyway, my scheduler round robin, it can change tasks in half a microsecond, quarter of a microsecond. I have interprocess communication. You can tell one task, Control B, Alt V. Okay, so right up here is the process ID, whatever you want to call it. It's the task record. We can send information to, let's send it to our buddy there, 3FD5FA. That's in the code heap, by the way. Directory character turn. New line. So I just told, anyway, so we have, it's trivial to do interprocess communication, all memory. You don't need to have a shared buffer. Everything is shared. There's one memory map for everybody. Scheduler commands. So I have some pretty nice string handling. We don't ever put a limit on a string length. We do everything zero terminated, and we have no limits because we don't care if somebody wants to crash it. That's their choice. If they want to overflow the buffer, that's their choice. We keep the code simple. We don't check for buffer, too big a buffer. We don't check for running out of memory. Anyway, we keep it simple. There's a limit of 100,000 lines of code. Okay, my printf is expanded. I started with the standard and I added new entries. You can do commas every 3 digits. You can do scientific notation or engineering notation. Anyway, scanf, you don't really, this is not really designed to read in and out files like Unix. It's more for a Commodore 64 type video game application. So you probably aren't really going to do, maybe you're doing a fun project, but it's not really for, what would you call it? Scientific work is what you would use printf and scanf. Anyway, this is the task, routine, spawn, and stuff. So I don't really have any algorithms. We have algorithms, we have LZW compression, we have a hash table, which is a data structure, we have qsort, which is an algorithm, we have malloc and free, which are just arrays of linked lists based on size, and it's a compound, so first you do in individual bytes, then you do 5 chunks of 512, then you do powers of 2. When you free, you put them in an array of linked lists, and so it can reallocate fast. It will fragment. In theory, you'll have to reboot, but that's okay because you do it anyway. It's kind of, anyway. So I could talk about the. We could go to the compiler. I already gave some nice videos on the compiler. This is kernel disk routines. Well, there's. What do you want to talk about? There's oh well, how about that?